Hello, everybody. It's me, Andres. I'll be covering what I learned this week in CS 4540 03 Intel Agents during week 2. So, today I'll be covering gradient descent. Recall in my last video last week um, that we talked about artificial neural networks and how they have an input layer, a hidden layer, and an output layer. And the way that a this neural network learns is through altering its different weights and parameters. Weights and biases and parameters. However, we didn't talk about how it does that. And in order to tweak all these weights and biases, we need an algorithm to uh, to to go and do that in a mathematically efficient way. So I'll be describing that algorithm called gradient descent. So it starts off with a cost function, and the cost function is basically the the summation of all of the differences in what a neural network's output is and what the output should be. So, for example, in this image classification case for the number 3, it should have only the number 3 output neuron should be activated, which is why you see next to the 0.97 that it's -1. Meanwhile, the other values are -0 because we don't want those neurons to be activated when we're shown a number that looks like a number 3. And what's interesting about when you add all of these up and average them, that you get a value that is small when the neural network is correct, or sorry, when you subtract them, when the neural network accurately classifies the image, and it has a large cost when the neural network is way off. And so the cost function, as I said, it tells the model mathematically when its output is incorrect and how badly, because of the cost could be very large versus very small. And the true key to machine learning, and trying to tweak these weights and biases to be the best, is to minimize the cost. And the way we do that is that we find the negative gradient of our cost function, and uh, uh, our cost function with all the weights as its input. And the vector that this will return is the direction of steepest descent. So, and this vector, which is the direction of steepest descent, will just look like a bunch of numbers, but when you add that to your original weights, which could also be represented as a vector, or also as a matrix, but vector in these cases. You could add the vector, and then that would nudge your weights. So to recap, you have what I learned about this week is I learned about the cost function, how we need it in order to tell our machine learning model that it did a bad job. And I also learned about negative gradient descent, which is the fastest way to calculate the mm, the vector that would nudge your weights in the right direction. And then the last step would be to adjust those weights by adding that vector. However, you only want to add the ones that get the most bang for your buck. So, for example, over here, you'll see values that are like point zero one or 0.04. These values are are less significant, or they influence the outcome of your model less so than numbers with a big cost function. And yeah, that's what I learned this week. Thank you for learning with me. Till next week.